Hi, this is the OUR Path to Research, an Office of Undergraduate Research podcast, where you'll learn about incredible variety of research here at McMaster University.
We'll be sharing tips, insights, and opportunities with students along their path to research. We are your hosts, Hussain and
Daisy. And so today we are thrilled to welcome Dr. Pat Clancy to our podcast. So Dr. Clancy is an assistant professor at the McMaster Department of Physics and Astronomy. His research focuses on condensed matter physics and quantum materials. Dr. Clancy is also an integral part of the McMaster Neutron Scattering Program, which operates two beamlines at the McMaster Nuclear Reactor.
today we'd like to learn more about Dr. Clancy's research and discuss the Undergraduate Nuclear Research Experience program. Dr. Clancy has been actively involved with the program and he has co-supervised students along with Canadian Nuclear Laboratory scientists. Mentioning Canadian Nuclear Laboratories, I do need to mention that this is a partnership between McMaster University and Canadian Nuclear Laboratories. This program, which began in spring 2023, has provided funding for undergraduate students in the Faculty of Science and Engineering. So far, two cohorts of students have completed their training, and a new cohort of students will join the program in May 2025. Dr. Clancy, thank you so much for joining us today.
Yeah, thanks so much. It's great to be here.
Sure. To start things off, could you tell us a bit about yourself, your research, and the space we're in, and this machine we got right here?
Yeah, absolutely. So, like you said in the introduction, I'm a professor here in the Department of Physics and Astronomy, and my specialty is studying quantum materials. So those are materials that have weird or unusual properties because of the role of quantum mechanics. So basically, our job is to try and design or make new materials, and then to try and characterize their properties. And so the lab that we're in right now is in the basement of the physics building. So this is the Arthur Borns building, for those of you who know your way around campus. And the instrument behind us here is set up to do electron diffraction. So this is one of the ways that we look at the structure of materials to understand where atoms are and how they're arranged with respect to each other. And that ends up being really important for understanding the physical properties that materials have. So my group works in a number of different labs around this building and on campus. So in addition to using electrons, what we do most of the time is use beams of X-rays or beams of neutrons. And it's really because of our interest in neutron beams that we've sort of aligned so nicely with the Canadian Nuclear Labs Undergrad Summer Research Experience program.
Awesome, that's really cool. Now, do you mind giving us a little bit of an overview of the Canadian Nuclear Laboratories research and maybe how it impacted your research?
Yeah, absolutely. So Canadian Nuclear Labs is in Chalk River, Ontario. So it's about 6 hours from here, north of Ottawa. And they do a variety of different nuclear research. So for myself, I started going there as an undergrad student, actually, many years ago, to use the NRU reactor. So this is, at the time, the most intense source of neutron beams in the country. And it was a national user facility. So folks would come from all over the country to do experiments, whether they were physicists or chemists or biologists, basically any type of research you could do with neutron beams. And so the NRU reactor has since shut down, but there's still all of this expertise in studying nuclear materials and understanding the ways that we can use these neutron beams to learn more about different types of materials and their applications. So this undergraduate student research experience program is a 16-week program that runs throughout the summer. It gives students from McMaster an opportunity to be paired with a McMaster supervisor as well as a CNL supervisor. And they spend part of their time here at McMaster working in our labs, maybe making materials, maybe doing characterization. Then they'll go up to Chalk River to CNL and they'll have 2 weeks on site there working with the CNL scientists and taking advantage again of some of these unique capabilities that that we can't find here.
No, that does sound like a great experience for the student in terms of their growth. But what do you think makes this collaboration between McMaster University and the Canadian Nuclear Laboratories unique in terms of the student opportunities and the research collaborations?
Yeah, that's a great question. So we have other undergrad summer research opportunities, and they're all very popular. What's sort of special about this program is its focus on all things nuclear. So it sort of interesting in the sense that it's quite interdisciplinary. So the people who are participating in this program, they're coming from different faculties, from different departments. It's really any types of projects that are tied in with nuclear science and engineering. And you get a chance to, again, take advantage of both the specialized expertise we have in that field here at McMaster, but also with our friends and collaborators at CNL.
And then could you possibly provide us some more insight on specific research projects that we can expect for this summer?
Yeah, so this is my third year participating in the program now, and this will be my fourth student who's gone through this project or this program. And so my group, I mentioned before, we are interested in making materials and characterizing them with neutron beams. And one of the things that we're quite lucky to have here at McMaster is the McMaster Nuclear Reactor. At the moment, the McMaster reactor is the most intense source of neutron beams in Canada. And it's the only place in the country where we can do these neutron diffraction measurements now. So most of the projects that my group works on involve using these neutron beams that we have just the building next door in the basement of the reactor. So in the CNL Undergrad Summer Research Experience program, we've tried to find places where the kinds of materials and techniques that we have here can sort of align nicely with the kind of things that CNL scientists are interested in. So one of those things that we do, we make these quantum materials, things like high temperature superconductors, and collaborated with a scientist from CNL, Dr. Zara Yamani. She's an expert in studying these superconducting materials and is now interested in seeing how these materials respond in high radiation environments. So you can imagine maybe you're designing quantum technology or sensors that are being sent into space or going to Mars, things that have to pass through a high radiation environment. And you might want to know how that affects the material and how it changes the material's property. So that's one of the things that we can do with the facilities that we have here. Another more applied project is looking at the properties of reactor components, so things that go into nuclear reactors. And again, the environment inside a nuclear reactor is quite extreme. There's high radiation fields, there could be high temperatures or pressures, and you want to know how materials respond in those conditions. And so we partnered with two other CNL scientists, Oksana Shiman and Kingshan Dong, and looked at either the residual stresses around different welded components that might go inside reactors, or we're looking at kind of hydrides that might form in reactor pressure tubes. So you can understand how these materials behave, you can understand when they might fail, or how you might be able to design better materials and components in the future.
That all sounds great. And then looking at the bigger picture, how do you think this program aligns with the current nuclear priorities in Canada? And how do you think this program can potentially impact opportunities in engineering and science in nuclear field in Canada?
Yeah, so that's a great question. I would say that, God, I'm biased because I work in the reactor every day, but I think it's hard to escape the idea that nuclear is going to be a big part of Canada's energy strategy moving forward over the next few decades, right? If we want to reduce our reliance on fossil fuels and still provide energy and to meet our needs for different types of technology and applications, then it's a case where we're going to need nuclear energy and nuclear technology. And so I think what's great about this program is again, you're taking students, you're introducing them to the world of nuclear science and technology, bringing them in, getting them an opportunity to see what kind of challenges are out there. What are the big questions that we need to try and solve to, design the next fleet of maybe small modular reactors, or find better ways that we can recycle spent nuclear fuel, deal with nuclear waste, build safer and more efficient nuclear reactors. And so, again, one of the challenges there is these are hard problems and they require all sorts of different expertise. This program is sort of a nice way to get people started in that world and to connect them with a lot of different people who know a lot of different things.
And kind of zooming in on the student aspect that you mentioned, but what are some possible skills or competencies that students can expect to acquire through this program?
Yeah. So I think think one of the nice things about this project is it is flexible, and depending on which group you work with, you can sort of tailor your experience to pick up the kind of skills that you're interested in. So the students that I've worked with in this program have largely started out by getting materials synthesis skills. So they've learned how to make new materials, to grow high quality crystals of new materials. That makes it easy for us to sort of explore the properties of materials in greater detail. And then they learn a variety of different characterization techniques. So again, if you're interested in the structure of materials, you should know how to do X-ray diffraction or neutron diffraction to see how the material is put together, understand the nature of the forces that are binding those atoms and keeping it together and shaping its properties. We also look at the magnetic properties of materials with neutrons or with something called a squid, which can tell us about different kinds of magnetic transitions that might be occurring in these materials at high temperatures or low temperatures or high magnetic fields. So once you understand these properties, then the next step is to try and tune them. And so the sort of third important thing that the students learn is how to use call sort of sophisticated sample environments. So how can you cool a material down to very low temperatures, to maybe 1 or 2 degrees above absolute zero, or how can you expose these materials to really high pressures to see how the atoms are moving around and how that's shaping their properties.
Okay, and as I said earlier, you are co-supervising students along with CNL scientists. So how's that experience been, and what role do you think mentorship plays in a student's learning?
Yeah, great question. So I've worked now with 4 students through this program, and I've really enjoyed it because when we started out, we were looking for projects that were in the areas that we already sort of knew what we were doing, and trying to find ways to sort of send that information to CNL. Last year, because we'd already been participating in the program, we had met new people through sort of events that run through this program, and actually started new projects. So in things that we weren't as familiar with, but gave us a chance to, again, take the tools that we have here and apply them to the problems that the CNL folks are interested in. So my background is in quantum materials. I don't really know much about what goes on inside a nuclear reactor, or what kind of materials problems they're interested in. And so in that sense, it was great to meet up with Oksana and Kingshan, who could sort of identify places where the skills that we have and the skills they have sort of come together. So one of the nice things you asked about mentorship, one of the nice things about this program is that it gives students very different kinds of mentorship. So it's great for them to be in a university research environment and to approach these things maybe from a fundamental physics point of view. But it's just as important for them to get out and see CNL, what's the industrial perspective on these things? People who are concerned about real practical applications, how do they approach these things differently? And how different is it working in a government research lab or industrial research lab? And so I think in that sense, the fact that they get 2 sets of mentors here at McMaster and up in Chalk River, I think that's been something that the students have really found quite valuable.
Awesome. And then speaking about Chalk River, could you possibly give us some insight on the value of it and also what stood out or some things that maybe could have been done differently to enhance the experience?
Yeah. So I think, the first part of that, what's sort of the special value of Chalk River. The Canadian Nuclear Laboratories has this really long history of world-class research in nuclear science and engineering. So, the lab has been operating since the 1940s, and they've done fantastic work for over 70 years. The neutron scattering techniques that we use here at the McMaster reactor were first pioneered at Chalk River using the NRX and NRU reactors. So Burt Brockhouse, who did some of the first neutron work there, later came to McMaster. He became a faculty member here, and later won a Nobel Prize in physics for the work that he'd done there. So even though that reactor is no longer operating, there's just this huge sort of treasure trove of expertise in using nuclear techniques and studying nuclear materials. So I think that's a great resource for us to be able to tap into and to send our students up to take advantage of. Yes, but what else we could do differently in the program? I would say this is only year 3, so in a sense, the program is still quite new, and it has changed each year, and I think changed for the better as well. So one of the things that's been really nice is that I think the second year we ran through the program, there was much more effort to match the students to projects that could take advantage of both sides of the partnership. So there was more matchmaking between CNL scientists and McMaster scientists. And I think that really helped. What would be great would be able to keep this going for multiple years. Because again, a lot of the research problems that we're studying aren't things that you can solve in a summer. So each of these undergrad projects helps us move the ball forward a little bit. But what you'd really like to be able to do is to keep that going, sustain it for 3 years, 5 years, 10 years, so that you can sort of grow these relationships and strengthen those kind of collaborations.
That's great to know you know what to improve on, and that shows growth. Okay, I'm going to throw a scenario question your way. Imagine there's some students that are interested in this program, but don't have a lot of experience in nuclear or engineering. They're unsure about it. What would you say to those students?
Yeah, so I would say, I think there's probably a lot of students who might find themselves in that position. And, I think the great thing about this program is it's not for people who are already experts in nuclear science, right? This is really supposed to be, the gateway, the introduction to these kind of science and engineering problems. So if you think any of this sounds interesting, if you're interested in the research that we do that touches in the nuclear space, or if you're interested in learning more about the kind of things that might go on at Canadian Nuclear Labs, talk to people who've been in the program, whether that's other undergrad students, whether it's professors involved. People love to talk about their own research. Bigger problem is getting them to stop talking about their own research. So reach out and ask people. But it's again, I would say for myself and for the students I've known who've gone through the program, they've really enjoyed it and have learned a lot by participating. Regardless of how much they knew at the start of the process.
And then my next question is, do you see this program improving the diversity within the nuclear workforce in any way? And if so, potentially how?
Yeah, absolutely. So I would say if you look at the cohort of students who have gone through this program in past years, one of the great things about it is a very diverse cohort. We're getting students from different backgrounds, different scientific backgrounds, different demographic backgrounds. Second years, third years, fourth year students from engineering and science. One of the nice things is traditionally engineering and physics have struggled with all varieties of diversity, so gender particular, but also racial diversity. That's a problem that's gotten better over time. And one of the nice things about these programs that target undergrad students is that our undergrad population is much more diverse. And so this is giving people who do come from more different backgrounds a chance to get a foot into the door in this new field, see what it's all about, and see if it's something that they enjoy.
Zooming out at the organizational level, what do you think McMaster gains from this partnership? And what do CNL scientists gain from this partnership?
Yeah. So I think that the great thing a program like this provides is benefits to both sides. I would say on the McMaster side of things, you get a chance to take advantage of specialized research facilities at CNL. So different kinds of characterization tools that we don't have access to here, different environments and labs that are set up for handling highly radioactive materials. And again, those connections directly to industrial researchers. So people who have the connections with nuclear power plants, who can come to you and tell you exactly what industry needs are or what problems they're interested in trying to solve. So that, at least on my end, has been something that's worked really well. In terms of how this benefits researchers at CNL, I think you get a chance to take advantage of some really talented undergraduate students. These are young and enthusiastic researchers who are just getting started. And, when they fall in love with a subject, they can be working on this for, the rest of their careers potentially. And so, we also have specialized facilities here that they don't have at Chalk River. So we have the McMaster reactor. We have access to these neutron beams. So especially in a lab that has been able to take advantage of neutron diffraction and neutron scattering historically, but no longer has those tools, I think there's a really natural partnership between CNL and McMaster here.
And then when you talk about students, has any of the collaboration with a student led to longer-term partnerships like securing joint funding or continuing the research after summer?
Yeah, great question. So I would say, again, we're sort of early on in the development of this program, but I can tell you that the first student who I supervised who took part in this program, Eileen Shanzila, she was a third-year undergraduate at the time, so she graduated and based on her summer research experience, decided that she really loved neutron beam science and decided to go to graduate school. She's now working jointly with myself and with another researcher at the University of Winnipeg, using the things she learned through this program to do her graduate research, to study the properties of new materials using neutron beams. We're still earlier on in the other project, so using our neutron beams to look at nuclear materials, but that's something that I hope will turn into a larger scale project, something where we're considering different grants to hire additional students, and again, to get something that could extend beyond just the 16 weeks over the summer. So yeah, I think as a way of sort of seeding these bigger projects, I think this is a great resource. Yeah.
Finally, looking ahead, where do you see this program going? Are there any goals or challenges that you'd like to see as it continues to grow?
Yeah, so like I've said before, I think the CNL Undergrad Student Research Experience program has been a great success so far, and I'd love to see it continue. It would be great if it could be renewed beyond this sort of 3-year trial run, because the longer you make the program, the more chance you have to develop and build these relationships and collaborations. It would be great if we could expand the size of it as well. One of the problems that we have is that there's so many great undergrad students here at McMaster, and there just aren't that many summer research positions that are available. And so you end up with far more people applying, with great track records and great qualifications, and there just aren't the resources to give them all something interesting to do. So this program is a great way to, again, fill some of that need to get these kind of targeted research projects in the nuclear space. And, the more people we can bring in this way, I think the better it'll be.
And then lastly, if there was one thing you wish people knew more about generally about nuclear research or specifically about this program, what would that be?
Yeah, so I think I'd say two things really. I would say, one thing is that nuclear science and engineering is a lot broader than people think. This is not just something that nuclear physicists do or nuclear engineers do. There are projects in here that are a great fit if you're a biology student, if you're a chemistry student, if you're a physicist, if you're interested in environmental science, that it's a really sort of active interdisciplinary field. And that's one of the things that makes it such an interesting field to work in. The other thing is that I think people are sometimes intimidated by assuming that they need to already have expertise or subject matter background. And the nice thing about a program like this that gives people a chance to get involved, after their first or second year, is that it's okay to be a beginner. All you really need is curiosity and interest in the subject matter, and that's really enough to get started. And the last thing I'll say, just so I have to put in a plug for neutron scattering, is that people should also know that this is the place. McMaster is Canada's nuclear university. We're home to the McMaster nuclear reactor. We are the only place in the country, one of only about 6 places in North America where you can do these kind of neutron beam experiments. And so if that is something that you're interested in, if you like materials, this is one of those avenues where you can get involved and find out about some of the exciting things you're doing there.
So for everyone listening or watching, we are excited to announce the launch of new nuclear minor at McMaster University. This is a unique opportunity for you to learn interdisciplinary knowledge and learn new skills in the nuclear field.
CNL has introduced a new scholarship for undergraduate students studying nuclear science. This scholarship aims to support talented students who demonstrate exceptional academic promise and a passion for nuclear sector. So Dr. Clancy, thank you so much for your time, and we'll be looking forward to seeing where your research takes you.